Hello students, today we will study the topic Fermi level in n-type extrinsic semiconductors. So this is the energy level diagram of n-type extrinsic semiconductors. It consists of valence band and conduction band. The bottom of the conduction band EC and the top of the valence band EV is well separated by a finite energy band gap, that is EG. The donor energy level is present below bottom of the conduction band, that is EC, and at the temperature of 0 degree Kelvin, the Fermi energy level lies at the center of EC and ED. So here we prove Fermi energy level in n-type extrinsic semiconductors lies at the center of bottom of the conduction band, that is EC, and donor energy level, that is ED. So here next is the proof. So we are considering that the donor atoms are present in donor energy level. Okay, then those donor atoms donated electrons to the conduction band. So we are considering that the concentration of electrons in conduction band is equal to the number of vacancies per unit volume in donor level. Okay, so we know that the concentration of electrons or number of electrons in conduction band is given by this expression NC into exponential of EF minus EC divided by KT, and the number of vacancies per unit volume in donor level can be represented by this formula ND into exponential of ED minus EF by KT. Here NC is the effective density of states in the conduction band. Okay, and ND is the effective density of state in donor level, where EF is the Fermi energy, EC is the energy of bottom of the conduction band, ED is the energy of donor energy level, and EF is the Fermi energy. Okay, and T is the temperature, and K is Boltzmann constant. Now this we know that the effective density of state in conduction band, effective density of state for electrons in the conduction band is represented by this formula 2 into 2 pi me kt divided by h square, where me is the effective mass of the electron and h is the Planck constant. Okay, now we will take natural log on both sides. What is natural log? Natural log means log to the base e, that is ln. So we are taking ln on both sides. So after taking ln on both sides, okay, here look at this left hand side. Here ln of a into b. Okay, here is also ln of a into b. So we will apply log rule, and we know that log a into b is nothing but log a plus log b. But here look at this second term is exponential term, and this is ln. So ln and exponential are inverse of each other. So this ln and e will be cancelled out, and only this power will remain EF minus EC by KT. Similarly, on right hand side is this ln and e are inverse in each other. E means exponential. So only the power ED minus EF by KT will remain on right hand side. Okay, along with this ND and this term. Okay, so by applying log rule, so we will get ln 2 into 2 pi me kt divided by h square to the power 3 by 2 plus EF minus EC by KT. Here ln and exponential, they are inverse each other, so they will cancel out. Here also ln ND plus ED minus EF by KT. Here is also ln and exponential are inverse each other, so they will cancel out. So we are left with these terms. Now this ln to same step I have quoted here. Okay, now we will shift the terms. So we will shift this term to right hand side, and we will shift this last term to left hand side. So this term will go to that side, will become minus, and this term will go to the left hand side. So here plus will become minus. So after shifting, we'll get this one EF minus EC by KT minus ED minus EF by KT. Here ln ND minus ln of this whole term. Now here is in denominator is common, so we will take common denominator on left hand side, and we will solve this term. Okay, we will open this bracket, and we'll get EF minus EC minus ED plus EF. Okay, by divide by KT. Here ln ND minus ln 2 whole this whole term. Okay, now in next step we will apply log rule again. We know that ln a minus ln b means log a minus log b is nothing but log a by b. So this ln nd minus ln of this term, okay, after applying log rule, we will get ln a divided by b, means nd divided by 2 into 2 pi me kt h square to the power 3 by 2. So we have applied log rule here. Ln a minus ln b is ln a by b. Now we will multiply kt on both sides. Okay, so multiply kt on both sides. So after multiplying kt on both sides, this kt will cancel. Kt divided by kt is 1 here. Okay, and ef plus ef, that is twice ef. Okay, twice ef minus ec minus ed here. So twice ef minus ec minus ed is kt ln of this term. Okay, now we will bring this minus ec minus ed to right hand side. Okay, we will bring this ec and ed on right hand side, so they will become plus. So twice ef is equal to ec plus ed plus kt ln of this term. Okay, now we will divide right hand side by 2. We will shift this 2 to the right hand side, so we will get ef is equal to ec plus ed divided by 2 plus kt divided by 2 ln of this term. Now we will consider at 0 degree temperature. When temperature is 0 degree Kelvin, second term of RHS will be 0. Since temperature is 0, so 0 multiplied by this term will be, so this second term of on right hand side will be 0. So we will get ef is equal to ec plus ed by 2. It means that Fermi energy level at 0 degree Kelvin, Fermi energy level lies exactly at the center of ec and ed. It means that ec plus ed divided by 2. So Fermi level, energy level in n-type extrinsic semiconductors lie at the center of bottom of the conduction band and donor energy level. So today we have seen where is the Fermi level in n-type extrinsic semiconductors, which is exactly at the center of ec and ed at 0 degree Kelvin, and we have proved that. So thank you very much.